Hello everyone, this is Praneeth, a second year undergraduate student from the Department of Aerospace Engineering and also a unit member of NSS Unit 5. Today we are going to discuss an interesting algorithm called Kadane's algorithm. Uh, Before going to it, first let us discuss a problem. It is called maximum subarray problem. The maximum subarray problem is the task of finding the largest possible sum of a contiguous subarray within a given one-dimensional array of numbers. For example, let us take an array. In this array, we need to find the maximum sum of a contiguous subarray. That means like a subarray can be -2, 1, 3, -2, 1, 4, or 1, 3, -3, 4, 4, -1, 2, 1, etc. We need to find the maximum sum of a subarray in this array. In this, the maximum subarray would be containing 4, -1, 2, 1. Hence, we need to return 4 plus 2 6 plus 1 7 -1 6. The naive approach or the brute force approach can be we will find every subarray which starts with -2, 1, 3, 4 and so on, and for in every iteration we find the maximum subarray starting with -2, and then we update the maximum with the by comparing the maximum subarray starting with 1 and so on. The code for the brute force approach would look like something like this. The outer loop will be to iterate over the array, and the second loop, inner loop, will be starting from the element which we need to find the subarray starting with that element, and then to the end of the array. We take a variable sum and update the sum variable every time by adding the element to the sum, and if we compare the sum with the max, and if the sum is greater than max, we update the max. We repeat this process so on till we end of the array, till we find the every maximum possible, every subarray possible with the element, like subarray starting with -2, 1, -3, 4 and so on, and we update the maximum. The time, since there are two loops, the time complexity will be O of n square. Then there comes the cadence algorithm, or the efficient approach to solve this problem. The simple idea of cadence algorithm is to look for all possible contiguous segments of the array and keep track of the maximum sum contiguous segment among all positive segments. Each time we get a positive segment, compare it with the max so far and update the max so far if it is greater than max so far. I know it sounds a little bit tricky. I'll explain it in the code. We take two variables, max so far and max ending here. Max so far is the maximum till where we iterated, and this is the loop. We start from the 0. Max ending here is max ending here plus a of I. Means for every iteration we add the value to the max ending till the left and add the element next to it. Since it is a contiguous sum, we'll find from till the max ending here from the variable and add the next value of the array. If the max so far is less than max ending here, max so far is the total maximum till we found here, is less than max ending here, we update the max so far as max ending here. If in a case if we add the element like it is more negative, like -10 or etc., if the max ending here is less than 0, then we update the max ending here equal to 0 and we will return the total max so far. So, to explain it further, let us go back to our main example. Let us discuss the dry run, or the how the algorithm is working through this example. Uh, since we initialize the max ending here as 0, we add -2 to it. Since it is less than 0, So we leave this item, leave this element and move on next, since it is not useful for us to find the maximum, since it is decreasing. Then we add 1 to the max ending here, since we declared again the max ending here as 0, due to since we added a negative number and the max ending here became negative in the last iteration. So since max ending here after we declared it 0, we added the 1, hence the max ending here will be 1, which is greater than the which is the maximum value we found till now, since we initialized max so far as int min, or the minimum value of the integer data type. So the max so far will be will be declared as 1 and updated as 1, and max ending here as 1. We move on to the next item or the next element. If we add -3 to the 1, that value is -2, which we obviously don't want, since we are happy with 1. The -3 is decreasing our value. So we update the max ending here as 0. That means we are leaving the array at the -3 and moving on to the next. And we are taking care of the 1, since we are storing 1 in the max so far, since that is the maximum value of subarray sum we found till there. Now we go to the to the element means to the 4, and we add 4 to the max ending here. Since max ending here is again updated with 0. Since 4 is greater than 1, we update the max so far as 4. We move to the -1. The since now the max ending here will be 4 minus 1, which is 3, which is less than the max so far. So we do not update the max so far and keep the max ending here as 3. Now we move on to the 2. Again we add the max ending here, since the max ending here is useful for us to find the contiguous sum when we are linearly traversing to the array. And we leave the array by declaring we leave at a point in the middle in the array if we found a value which is less, which we feel is negative after adding it, so which is not useful for us to, so we leave the array and move to the next item to find the maximum, like we did when we found -3. So here after finding 2, our total maximum value would be 4 minus 1 3 plus 2 5, which is greater than the 4, hence we update it as 5. The similarly at 1 we update the max so far as 6, and when we come to the -5, the max ending here would become 1, which is less than 6, so we do not update it. Again when we come to the 4, the max ending here would be 5, which is less than 6, so we do not update anything. So at the end we would left with 6 as our answer and we return it. So this is the main idea behind the cadence algorithm. The things we kept in mind was when we add a negative number which is greater, means which essentially makes our number as less than 0 after adding it, which is useless or very, we don't need it, since we need to find the maximum subarray sum. Hence we declare the max ending here as 0. That essentially means we leave the array at that point and move the next item, and we repeat our process to find the subarrays which have the maximum sum at after them, and we update the maximum every time if we found by using the variable called max so far. I think you have understood the problem and the algorithm. Since it is a one iteration, the time complexity will be O of n, and we use the constant space here, since it is an efficient way of solving this problem. I hope you have understood the code and the approach to solve this. Thank you.